How does inertia welding work? Basically, by forcing together pieces to be joined in such a way that rotary motion and pressure are converted into heat, which literally bonds the pieces into one part. Two pieces to be joined are aligned in an inertia welding machine. One piece is held stationary, the other is rotated rapidly on a spindle chuck attached to a flywheel. When the flywheel reaches a predetermined speed, it is disengaged and the freewheeling piece is forced against the stationary piece. Friction between the parts heats the budding surfaces to forging temperature. Just before rotation ceases, the two pieces bond automatically. When the flywheel stops, the weld is complete.
With the aid of high-speed photography, we can see a projection weld as it takes place. A resistance weld is the result of steel components under pressure for a controlled period of time with current flowing, creating sufficient heat, causing the metals to coalesce. When current ceases to flow and the area begins to cool, you have created a permanent bond. The basic factors for a resistance weld to take place are heat, time, and pressure. When these factors are in proper balance, an optimum weld will follow. This applies to both spot and projection welding. Properly installed Ohio weld fasteners will provide an excellent attachment method without the need for secondary operations. Typical weld setups for Ohio parts welded to C1010 low-carbon cold-rolled sheets in a thickness range of 0.025 to 0.187 can be found in the weld data section of the standard Ohio weld fastener catalog. We have used these setup guidelines in all of our examples that will follow. We begin our weld demonstration with Ohio parts designed for spot welding. The first example is our XN style weld nut. The XN's narrow body enables it to be welded in corners and confined areas. The XN has a precision locating pilot, full threads, and is countersunk for easy entry of a mating part. As with all spot welding, the diameters of the electrode tips are extremely important as they control the size of the weld area. The basic spot weld technique of using a smaller diameter electrode tip on the thicker part and a larger diameter tip on the thinner material side is being used. On the 1/4 20 and smaller XN sizes, there is a target area of reduced thickness. This creates a more favorable balance of material thickness when the XN is welded to lighter stock. Our SS-style spot weld spade screw has an ideally shaped flat spade at right angles to the threads. The spade permits welding to or through metal surfaces. The spade has been designed to be used with various sizes of electrode tips. It is designed to fit in confined areas, such as narrow channels, walled corners, and in those applications requiring threads offset from component surfaces. Again, the smaller diameter electrode will be on the thicker material, in this case the spade of the SS weld screw. Our final spot weld example will be an Ohio TP, a twin-piloted spot weld nut. Use of the Ohio TP nut eliminates the need for two individual nuts.
Very high electric currents are used to quickly produce the resistance heat necessary for fusion. The three principal types of resistance welding are spot welding, seam welding, and projection welding. Spot welding refers to making welds one at a time between the electrodes. One, several, or many individual spot welds may be required, depending on the application. Spot welding, with the electrodes maneuvered by articulated arm robots, is commonly used to join sheet components of automobiles. In seam welding, coordinated pulses of electric current from rotating wheel electrodes produce a series of overlapping spot welds, resulting in a leak-tight welded joint. In projection welding, the welds are localized at predetermined points by projections, embossments, or intersections. Several points may be welded simultaneously.
At NSRW, we take a different approach. Our goal is to anticipate rather than react to your production needs. Customer education is vital to our success, and we are committed to the support and improvement of your entire welding process, from the raw materials to the proper equipment specifications. We evaluate, we advise, and we offer solutions. By calling NSRW, you have enlisted a team of experts, professionals who are available to you 24 hours a day, 7 days a week for emergency service. NSRW is a metal service center. We specialize in copper and copper alloys. Our inventory includes chrome copper, zirconium copper, beryllium copper, copper tungsten, pure tungsten, and molybdenum. We stock rounds, squares, rectangle bar, hex, and plate. Our vast inventory allows for immediate shipment, most times same day. Our inventory also includes a full line supply of welding components, from standard and special electrodes to controls, transformers, cables, and shunts. We customize our inventory for your specific needs, allowing us to offer just-in-time shipments for your convenience. We rebuild and retool old equipment, and we offer application and service engineers trained and experienced in all aspects of resistance welding.
A resistance spot welder is designed to deliver a low-voltage, high-current electrical pulse. The weld electrodes are made of copper because copper has a low resistance to current flow, which allows it to conduct electricity with ease. Steel is a very poor conductor of electricity, and it will resist the weld current as it flows from the spot welder. The friction created by the current forcing its way through the metal heats the weld area to over 2,000 degrees Fahrenheit. The squeeze pressure from the weld electrodes now compresses the molten area and fuses the two metal surfaces into one solid nugget. By maintaining the squeeze pressure for a short time after the weld current is shut off, which is known as hold time, the molecules in the welded material remain compressed as the weld cools. This additional pressure results in a much stronger weld. Electricity in your shop, how it works, and why you need to understand how it affects the performance of your welders and other equipment. Single phase. This is how the electricity is delivered from the electric company. When viewed in an oscilloscope, you can see the current as a sine wave form that alternates between positive and negative polarity across the zero line. This form of electricity is called alternating current, or AC. The frequency of the wave cycles is always consistent, and it is measured in cycles per second, or hertz. 1 hertz is one complete wave of current starting at zero, moving up to the maximum or peak level, falling down through zero, and then up again from the negative peak to the zero line again. Let's look up close at one sine wave. The AC current waveform alternates through the zero line from positive to negative. At 3 different times in one cycle, the power is zero as the current completes the cycle. This means that there are inherent losses involved in AC power. The losses result in inefficient use of available power, and when used with resistant spot welding, the weld quality is negatively affected. As you can see in the slow motion graphic of this spot weld, there is an irregular, pulsating 60 Hz delivery of current.
Get 3-phase power from the electric company if you want to use better welder technology for better welds. The entire waveform starts out as a single cycle, but it is followed by a second sine wave delivered 120 degrees after the first one, and a third sine wave is started 120 degrees after the second one. Remember, AC current has 1 sine wave per cycle, but 3-phase current has 3 sine waves.
Arc stud welding is generally used to weld large diameter fasteners to more porous and thicker base metals. A fastener and ceramic ferrule are firmly placed against the work surface under spring tension. Upon triggering, the weld gun automatically lifts the fastener from the base metal and initiates a controlled electric arc which melts the end of the fastener and a portion of the base metal. At the precise moment the fastener and the parent metal become molten, the fastener is automatically plunged into the work surface. The metal solidifies, and a high-quality, full cross-section, full penetration weld is completed.